Space is often described as an almost empty place, filled with darkness and separated by enormous distances. But every so often, astronomers discover something that completely changes that picture. For decades, the Hubble Space Telescope has captured distant galaxies, exploding stars, and events that happened billions of years ago. Most observations fit into the scientific picture we already understand. But occasionally, Hubble finds something so strange that scientists have to rethink what they're looking at. That happened when astronomers discovered an extraordinarily long, narrow trail of young stars stretching across hundreds of thousands of light years. It was unlike the familiar structure of a normal galaxy. Instead of appearing as a conventional collection of stars, the feature looked more like a giant cosmic streak. The stars along the structure were unusually young and blue, suggesting that they had formed relatively recently. The enormous amount of star formation raised an immediate question. What could possibly create such a long, organized trail? Astronomers considered several explanations. One possibility was that the structure might simply be a galaxy viewed almost perfectly edge-on. From the right angle, a flat galaxy can look like a thin line. But the properties of the stars did not behave as expected for an ordinary galaxy. Their ages and distribution pointed toward something much more unusual. Another possibility involved a powerful jet from an active galaxy. Supermassive black holes can produce enormous jets of particles and radiation. When those jets slam into clouds of gas, they can sometimes compress the material and trigger new star formation. That explanation also struggled to match the observations. The shape and location of the star-forming region did not behave like a typical jet-driven structure. Some of the strongest signs of energetic activity appeared toward the distant end of the feature rather than where a conventional jet would be expected to have its greatest influence. Then came the more extraordinary possibility. What if the line was not a structure sitting in space? What if it was a trail? Astronomers already knew that black holes can potentially be thrown out of galaxies. When two supermassive black holes merge, the gravitational waves they produce can be emitted asymmetrically. That imbalance can transfer momentum to the newly merged black hole, giving it a powerful gravitational recoil. In extreme circumstances, the recoil could send the black hole racing away from the center of its galaxy. For decades, this phenomenon had been predicted by theory and simulations. But finding convincing observational evidence for a supermassive black hole actually traveling through intergalactic space would be an entirely different matter. The mysterious stellar trail provided a possible clue. Imagine a massive object moving through a cloud of gas at enormous speed. It would disturb and compress the material around it. A shock wave could form ahead of the object, while the compressed gas behind it could eventually collapse under gravity. If the conditions were right, that collapsing gas could form stars. In other words, the object would leave behind a trail of newborn stars. That idea was extraordinary, but astronomers had another reason to take it seriously. The structure appeared to have characteristics expected from a fast-moving object interacting with surrounding gas. Follow-up observations provided additional information about the region, including evidence for shocked and energized gas near the end of the feature. The observations strengthened the possibility that a massive object was moving through the surrounding material rather than simply sitting inside a normal galaxy. The proposed culprit was a supermassive black hole. Estimates placed its mass at millions of times that of the Sun, while its inferred velocity was on the order of 1,000 kilometers per second. At those speeds, the black hole would be moving through its environment like an enormous gravitational projectile. But the most fascinating part was what happened behind it. A black hole is usually associated with destruction. Its gravity can tear apart stars, disrupt planetary systems, and pull matter beyond the event horizon. Yet in this scenario, the black hole could indirectly trigger the birth of stars. As the black hole moved through gas, its gravitational influence and the shock wave in front of it could compress the surrounding material. Once that gas became sufficiently dense, gravity could take over. Clouds collapsed. Dense clumps formed. And eventually, some of those clumps could ignite nuclear fusion. New stars were born. That creates one of the strangest contradictions in astrophysics. An object associated with extreme destruction may also create the conditions required for new stars to form. But the mystery did not end there. Astronomers wanted to know where such a fast-moving black hole could have come from. The answer may lie in its trajectory. If the object really was moving away from a particular galaxy, scientists could theoretically trace its path backward. That path could reveal the event that launched it. And this is where the story becomes even more dramatic. The suspected origin involved a disturbed galaxy system created by a major interaction between galaxies. Such collisions can bring their central supermassive black holes together. At first, the two black holes orbit one another. Their separation gradually decreases. Eventually, they merge. The resulting black hole does not necessarily remain at the center of the newly combined galaxy. If the gravitational waves from the merger are emitted asymmetrically, the merged black hole can receive a powerful recoil. It can be kicked away. In an extreme case, that kick can be strong enough to send the black hole far beyond its original galactic environment. So the sequence could look something like this: two galaxies interact. Their central black holes eventually merge. The gravitational wave emission produces an asymmetric recoil. The newly formed black hole receives a tremendous kick. It escapes into intergalactic space. And as it travels, it disturbs surrounding gas and potentially leaves behind a trail of newly formed stars. That would turn a violent black hole merger into the beginning of an entirely different cosmic journey. The idea also raises a much bigger question. How many runaway black holes could be traveling through the universe right now? Galaxy mergers are common on cosmic timescales. Supermassive black holes are thought to reside in the centers of many large galaxies. When those galaxies merge, their black holes can eventually interact. Not every merger will produce a powerful enough recoil to eject the resulting black hole. But some could. That means there may be many wandering supermassive black holes that astronomers have not yet identified. Some might be moving through galaxy clusters. Some could be far between galaxies. Others might still be close to the galaxies that launched them. And some could potentially reveal themselves through unusual star-forming trails. There are already other intriguing cases that astronomers have investigated. For example, the giant galaxy at the center of the Hubble 2261 cluster has long attracted attention because its expected central supermassive black hole has been difficult to detect. One possibility that has been explored is that the black hole may have been displaced or even ejected following a previous merger. Other galaxies contain black holes whose apparent motion or position does not perfectly match the surrounding stellar system. These observations do not automatically prove that a black hole was kicked out, but they provide interesting targets for further investigation. The important point is that one unusual object can open an entirely new area of research. If astronomers eventually identify many runaway black holes, they could begin estimating how frequently black hole mergers produce strong gravitational recoil. They could also learn more about how galaxies change after losing their central black holes. That matters because supermassive black holes are not isolated objects. Their activity can influence the gas, stars, and overall evolution of their host galaxies. If one suddenly leaves, the consequences could extend far beyond the black hole itself. There is another fascinating possibility. Runaway black holes may not simply travel forever through empty space. A wandering black hole could eventually encounter another galaxy. If it becomes gravitationally captured, it could sink toward the center and eventually interact with that galaxy's central black hole. That could lead to another merger and another gravitational recoil. In principle, this creates a cosmic chain of mergers, captures, and ejections unfolding over billions of years.